Couple things about machine learning that are kind of interesting. Let me just do a sketch here and just talk about it. The Yeah, actually, I already have something. I might as well just use what I already drew. So with machine learning, there's really three ways to think about it in the world we're in right now. There's probably more, but this is just an idea of how to think about it. And you've got do it yourself. And so that's one of the things I'm going to demo in a second is more of a do it yourself machine learning model where you take, let's say, a scikit-learn app, you serialize out the model to disk, you pull it into Flask, you take that Flask app and you deploy it in some system, like maybe you deploy it in App Engine, or you deploy it on AWS has Elastic Beanstalk, or maybe you use Kubernetes and you deploy this application. Now, there's pros and cons to that. The pros of it are it is nice that you know every single component, you can control it, you can basically run it on any platform, Azure, AWS, Google Cloud, IBM, Oracle, Ali Cloud, whatever cloud you want in your own data center. But the downside of it is that there are a lot of gotchas that come up with machine learning that really are need to be thought out. So again, if you look at this COVID-19 problem, what's interesting about it is that there's so many complexities involved with it that many uh, people in government don't really understand, except for the doctors understand it, right? Is that okay? If I say that we're good and that we're not, then there's a big problem, right? Or if I think I know who has the virus and who doesn't, and then then I make a mistake, then how do we understand who has the virus? There's all these kind of gotchas everywhere where there's exploding complexity, right? Where does social distancing work? What does what? It's the same thing with machine learning. Is there's exploding complexity, and some of the exploding complexity is that what if your model has changed, right? So what if you trained your model on some data? Let's use COVID-19. Let's say you trained it on New York, and you say, okay, now I know how to predict who's going to get the coronavirus or COVID-19, and it turns out that New York is totally different. So your model doesn't work. The same thing happens if you're training a model that shows people products, and all of a sudden there's a new section of customers. It may not work, and how do you know that that's a problem? So you may need to have some kind of A/B testing infrastructure, and if it's a do-it-yourself, then that may not be even an option. Or another one is, what if the scalability of your system needs to dramatically go up, right? What if you need to add more and more inference nodes that do the predictions? How are you going to do it? Do you know how to manage that? And so, there's that's one of the dilemmas of doing it yourself, is that there's a lot of gotchas that maybe you think you understand what's happening, but in practice, you don't. Like again, one of the funny things about, I mean, there's not much funny about the crisis we're in, but if you look at pundits who are, very basically very uneducated that are on television, they're very confident and they say things like, "Oh, there's this or there's that," and it turns out that 2 days later they're completely wrong. That that's one of the downsides of there's actually a word for this. It's called Dunning-Kruger. Is the more confident you are, the less you know typically about something. So with machine learning, if you're really confident that everything's working because you did it yourself, that's scary because there's probably a lot of things underneath the hood that you don't know what's happening, and they could come back and really cause problems. So that's why, and this is the other thing I was going to show today, is these platforms. The good thing about the platforms is that you can really bet on the vendor of that platform to do a lot of the heavy lifting for you. So in the case of AWS SageMaker, they handle all the things I talked about. They have, A/B testing, the training can automatically scale up. The prediction itself, you can do alerts on it, and so it's kind of designed for you to be successful, and it has lots of guardrails and protections in there so that you don't necessarily have to do every single thing yourself, and maybe be unaware you have a blind spot somewhere that's really going to hurt you. Spark, the EMR system, has some of those same characteristics with it. The one I was going to show today is called AI Platform on Google. It also has some of those characteristics where it can manage a lot of the complexity of a model. And then there's the most automated, which is the AutoML system from Google, or AWS has SageMaker Autopilot as well. So these AutoML systems, there's also a lot to like in that. In some cases, why not use AutoML? Let's say it's computer vision problem. Again, going back to chest X-rays, what would it hurt to use AutoML, get a prototype working? If it's good enough, it solves a problem. Why get into the complexity of building all that stuff yourself when you can solve the problem really quickly with AutoML? So there's probably other ways to divide up machine learning at scale, but it's just something to consider. I think that this middle ground is probably in the real world the best solution for many problems if you have to solve the problem yourself. And then if you need to rapidly get results on something, I also think the AutoML. I also think the AutoML is a good solution as well. Any questions about any of that? Okay, so next up, let's get into let's see here. So yes, okay. Yeah, so it's a good question. So with the you have a lot of flexibility with ML, with these ML platforms like SageMaker, for example, because you can pretty much do anything, and they focus on operationalizing the ML model. So they assume that you can train the model, and then they give you the tools to operationalize it. So in many cases, I think those are good choices. Now, AutoML is still in the early stages. The things that AutoML can solve, computer vision is actually very effective with AutoML. And in fact, yeah, I might as well just get into that a little bit, the AutoML as well. We'll see how far we can get today. But the computer vision is pretty good with AutoML. There's also classification works pretty well as well. And then the pre-trained models, I guess I should put there's another category which would be so there's pre-trained. So we'll call this AI API, and that would be a fourth category. And there's a lot to like about that because you don't have to do anything. You don't even have to click a button to tell it to train. They've already worked on the API for you, and they can do object recognition, NLP. So really, this would be category one, this would be category two, and then this would be category three, and then this would be category four. So yeah, let's get into let's start with the highest level one real quick, and I can just kind of go through this, then show you a little bit AutoML, and then show you a little bit of platform. If we run out of time, we can just dive into next week. So the in terms of computer vision here, let me just get this going. I'm going to assign it to AWS, and I'm going to do a password here. So we'll say auth code. Okay, 153. Okay, so in terms of AWS Cloud9, we've had a lot of good experience with that. One of the things that you can do with it is you can also use it to prototype out an environment that uses AI APIs. And so I'm going to also open another tab here, and I'm just quickly going to show you recognition. So this is a pretty nice tool from AWS that allows you to do basically things like object detection. And you can see that this picture, it's able to pick up all the stuff and show it. I'll upload another picture I have on my desktop here of, let's see, this I think is a San Francisco bookstore, city lights and bookseller. And you can see that it's able to detect people. It's able to detect that there's a shop listed, right? So this would be another one of, if you needed to solve this kind of a problem where you needed a system to take a bunch of images and classify pieces of it, and then maybe you bring that into some other machine learning model. It's a great system to use. Why not use it? And also it can do things like find text and images again. So if I take that same image here, and I put the text in there, or put that same image in here, it should be able to detect some of the text from it. You can see here, right? Paper, bookseller, publisher. Like it was able to mostly. It's not a great picture, but it's able to get a lot of stuff out of this. In fact, even gets like things I can't even read. It was able to pull them out of this image. So it's one thing to play around with it in here, but one of the things that's really cool about it is you can actually, and it also does like, facial comparison, celebrity recognition, all this stuff. We can go back into Cloud9 and actually programmatically talk to it as well. So I think I have a project here, computer vision API, I think. Let's try this. And we could actually just dump things into Amazon S3, like images, and then either do event-based recognition or event-based workflow, or make a API with a basically Lambda an API gateway. So all stuff that we've done before. And I think this is actually not used as much as it could be used because it directly solves the problem for a company. If you can use off-the-shelf software and create a solution for someone very quickly, you're going to be very valuable to an organization. Um, let's look at this computer vision API project here, and what I can do is maybe quickly create a Python virtual environment. So let's say Python 3 -m, and we'll just call this CV, and then I can go and source this thing, then activate, and then I think I have some code here that I was using that will do some computer vision, and I'll share this in Slack as well. So I will find this. It was computer vision. Yeah, so there's a whole repo of stuff I have for a computer vision class I teach, and I think it's here. Or do I have a Lambda in here actually? Lambda function. Yeah, this looks pretty good. So I can look at I can just grab this thing and just paste this into my environment here. So I can go ahead and uh, basically make a file called detects, and then we can use the editor, and I can just use a script here and kind of just, in this case, I have a bucket called December 27 computer vision, and I have a file in there. So I'm going to just tweak this a little bit and just pull out this part of it, so that I can just run it as a script first. So let's see, somebody has a question. Yes, this is being recorded. So this here is, I'm going to make another file here just called scripts. So we'll call this scripts. And if you remember, I had that image of the books, the bookstore or whatever. So I'm gonna just kind of delete this start part. So I have a all this is gonna do is it's going to use, and I don't need that even for script, is going to use the Python API, which is called Boto3 for AWS, and it's going to do it's going to exactly do we what we told it to do in the console. So I don't think I need that. I think this should just work, detect, and then I would just need to call this function down at the bottom. So I'll say detect like that. Detect, yeah. Um, so I can, in order to run this, I would need to install Boto3. So that's the first thing I'll need to do. So we'll say pip install Boto3. And then the next thing that I will need to do is set up this. I need to make sure there's a bucket that corresponds and an image that corresponds to whatever is put into here. So if I go back to the S3 environment, and I'm going to just reload this real quick. In fact, I already did this. I did a demo on this yesterday, but you can see that this is a bucket called demo April 10th. And I have actually put this new file that we were doing the picture of that bookstore. I'll put that inside of here. And it's this, just like that. And then I can, you can see there's this image. So I can just click on this and copy the path, go back to this script here and paste this in so that it's got the name of the image in the bucket. Wow, that's a huge name of an image. And I can take this out. It doesn't need the S3 part. And then I also need to tell it the bucket that it lives in. And the bucket it lives in is called demo April 10. So I'm going to just change that to say demo April 10. And if this is correct, this should get, there we go. This should allow us to use computer vision in a script. I'm going to just run Python scripts, and does it work? Unable to get, it could be that I misspelled something, or would not surprise me. That's such a weird name. I'm going to rename it so it's less long. I'm going to rename it like bookstore, and then I'm going to upload it again so that I don't trip myself up. So I'm going to go back to demo April 10, upload this file, bookstore. And I think I know what the issue is actually now that I think about it. I just need to go back here. It doesn't need this path. That was the problem, but I fixed it anyway. So you only need to put the key of it. So I think this is called bookstore.jpg. Yeah, you don't need the path, just the name of the key. Okay, if I save this, if I run it again, there we go. So now it's able to detect and give us back a JSON payload that has all kinds of information about that bookstore. So again, I think why would you do this yourself, train some ML model if your company wants you to solve a problem for them really quickly, or you need to somehow use this as an input to another machine learning system, why not? I mean, look, this is like 10 lines of code. Even further, the other thing we can do, because now we're all experts in the building Lambda functions, is why not build it into an API? So what we can do next is if I click on this, I could go here, make a new Lambda function, and we'll call this CV API. And then I could go to runtime Python 3.6, go to a trigger, use API gateway, and we could put in a path here called image. For security, say none. And then this is the part that I think I talked about earlier that will really trip you up, is you must create an IAM role that has the privileges to make an API call on your behalf. That's really the trickiest thing to do. We've done that before, so I won't do it again, but I'll choose one that has administrative privileges. Here we go, admin dev. I have an admin role for Lambda. It can call recognition API. We say next. And now I can just take I think I had this Lambda code already that I had used, I don't know, a few months ago. I'm going to just paste this in here and just see if it mostly works. I need to also take this bucket stuff out of here. So I'll just change the names of the bucket. So go here. Yeah, we just swap these out. Whoops, wait. Let's do that. S3 object. Okay, that looks good. Just double checked. Maybe, yeah, image, S3 object. Looks good. Why is that? Wait, why does that look? I guess they have this. This one is. It shouldn't matter, but so you pass in a name, and then the name would be this. So I can take this out, so that we basically can build an API, um, and then inside of here, in the body of our Lambda handler, we'll accept the payload, and then we should look for the word name in the payload and then pass that name into this Lambda function, so that basically it can do computer vision on anything that would live inside of our S3 bucket. So what I can do here is just test this out, and I think that this. Oh, the one thing that we would want to do that can trip you up is, let me just go to Lambda real quick, is you want to return back the right payload. So what we want to do is go to Lambda real quick here, reload this, and let me just look at the right return payload. So if we go here, in fact, I think I already have some code in here that does this. Overview. Maybe I just even copy it. Nope. That's not what I. Let's see, detect image change. Let's try this one. And yeah, this is kind of what I want. In fact, I'm just going to copy this because I know it works. I'm going to go, it's similar to what we just did. I'm going to go back to this and just swap this out here. And you can see that I have a Lambda handler here that does recognition. It takes in an image though. This is the difference, instead of name. And then this is the part that I was looking for, is that when you're doing an API with Lambda, you have to return back a status code, which is the HTTP status code, so that an API knows that the response was successful. If you don't do that, it acts weird. And then also you have to return a JSON response. So this is this code. I'll put it into a gist here so you can see it. Or actually, you know what I'll do is I'll just put it into this computer vision library. That's probably a good spot for it. So if I go back here and I go to computer vision, and I can just make a new file in here and call this lambda CV or something like that. And then I can paste this in here and save it. And then I'll put this into Slack. So lambda CV, there you go. Okay, that works. Now what we can do is go back to our Cloud9 environment that we've been setting up here, and I can test this locally. So if I right click on it, I can say run local API gateway, change this to a get, and then I can say image, and then pass in that bookshelf or bookstore.jpg. There we go. Run it, and it may not work or it may work. I've noticed sometimes that this thing, the first time I run it in here, it doesn't it doesn't always work. But what I'm going to do is I'm going to deploy it and see if it works when I deploy it. So, oh, maybe I didn't save this. Is that what the problem was? Let me test it one more time now that I've saved it. I'm still having a problem, but I'll and I guess I would need to redeploy this. There you go. I'll deploy again. So now that it's deployed, let's test it out in the Lambda interface here, which is this one. And let's just double check the code. If I click on it, we can see that looks correct. Oh no, see this is that's why it was having a problem, is that it needs to return back the JSON payload. In fact, this is old. This is not the code I was looking for. There we go. So this is a new code. So maybe that was why I was having a problem. But what I'm going to do next here is now just test this out. So we know that it's going to look for something called image. If I go here and I create bookstore, and then I just put in there, I just put image bookstore, image bookstore, like that. This will give us a bookstore, hopefully, that will, unable to, it said, error occurred, unable to get object detected. Maybe I made a mistake here. Oh, good call. You're right. That was it. Okay, so um, that is exactly what the problem is. I'm not giving it the right name. So if I go through here and I save this and I test it, there we go. So now we got it. So now we can look. You can see the labels, right? It has all these labels. And what's cool about this is that it's also an API as well. So if I go to API Gateway here and I look at this is actually the endpoint, and I can test it a bunch of different ways. But one way to test it would be to go to this, which gets us into Cloud9, and it is pretty cool because it will let you test it here by going to post, and then you can put in the same thing. You could in theory, we'll see if this works. If you say image and then do bookstore.jpg like that, and we test it, does it work? There we go. So this is actually pretty cool because I don't have to do a curl command to test it out. And so I mean this is like building a production API that does computer vision. Now I also could grab this and then go back to, let's say, Cloud9. And this is kind of a neat little trick, is open up a terminal here. Let's make this smaller. And then I could just maybe do this, just paste this in here. This is a little trick to be aware of. If you put a hashtag, you can kind of keep it in memory. It doesn't like blow it up, your shell, and I can go back to it. So what I'm going to do is I'm going to find the curl command. I have a curl command. Yeah, this is the one I was looking for. Remember we did this last week. I'm going to just tweak it a little bit. So I'm going to go back to here, and I'm going to take our old curl command, and I'm going to kind of piece it together. So I'm going to say curl, that looks good, which is, the first part is send it in, tell it that I'm going to make a JSON request, and then I think you can do this. You can kind of wrap the lines like, I forget how you wrap the lines. Why am I messing that? Is it like this? No, it's this other way. Yeah, you can wrap lines together so you make it a little bit cleaner. And then I can say request post, and then wrap it again. And then I can say give me the data. And then this is where we would put in our payload. So it would be this, which would be, instead of entity Google, it would be, and let me just move this up a little bit if I can. Just move this up a little bit. Yeah, it would be image bookstore image. Actually, let's be fancy and let's find another image in there, and let's find windmill.jpg. So this time I'm going to type in a new image called windmill.jpg, and then I'll do the wrap again, and then I will put in the URL, and that was this URL. So in theory, this would make the API call if everything, again, I'll make this a little bit bigger. Let me just drag that up so you can see it. Woo, that is not what I was trying to do. Okay, here we go. Oh, is it? Ooh, good catch. Yeah, that would have not worked. Um, so Control A. Ooh, that's irritating that you can't. It. Oh well. Well, this one will fail, and we'll have to do it again. So um, let's do it one more time here. Um, this is what's irritating about doing curl commands is that you have to. That's why people like to use other tools like there's Postman, there's the API gateway thing, and then you're right. That was that will get you right there. That's a easy mistake like that. And then the last one would be the actual. I would have to do space. I have to do because I made a mistake. I didn't put a space after that, and then I could do this. I'm gonna have to go back here now and find this URL, and then this should be able to make it. It should be able to make this request. Let's see, does this work? Well, port number ended with. I guess I can be lazier here and do this. Let's just say we'll call this API.sh. This is going to be easier, and then just literally build a shell script. There's just too much stuff going on here. So I can take all that stuff I had before. So I'll do curl content type, add this to it, wrap this around, and then I think I didn't put spaces for everything actually. That might have been the other problem. And then I could go here, request, post, again, space, and then I could go to data. And again, I need to do a space. I think that was what I was messing up. I wasn't putting spaces here. This also shows why it's irritating to do curl commands. And then I can just type in bash API. There you go. So we got it working. So I'll throw this into a gist as well, just so you can see here. Let's go to these gists and make a new one. And we'll call this curl API computer vision. And I'll make it a secret, and then I'll throw this in there. So you could actually do the same thing if you want to call this API. I just gave you access to go into my. You can basically do computer vision on anything I have in that bucket. So you could make the same API call. So I made a production system. So I think that hopefully shows some of the power of when you use these off the shelf AI APIs, what you could build. And obviously you could go back to this if you wanted to add other triggers. These can actually have multiple triggers. So you could have it could be an API plus it could respond to S3 events. So you could maybe even have something where you're dumping a bunch of images into S3, and every single time you dump an image, it does computer vision and it puts it into, let's say, DynamoDB, and then holds a bunch of metadata. And then later you have SageMaker read from that and then use it for a machine learning model or something like that. So that's the AI API. That's like the highest level. Let's now go into the auto. Let's get into AutoML on AWS. So AWS has something called machine learning, which is here. And this is an AutoML solution where you don't have to write any code, and it will create machine learning models for you. So if I go to this machine learning dashboard here, the way it works is I can let's take one of the ones I've done before here, like this AutoML, and let me look where I put the data. I think I need to look at data here. This would be banking, and I just need to find where the data is at. It's in here. It's going to be data sources. That's where it is, and I'm going to look for this. Okay, so where is this? It should tell me where. Wait, use this data source to. Why is it not telling me where this file lives? I need to tell it. There we go. This is what I was looking for. So you just like we did with the computer vision, you need to have some file somewhere that has a bunch of data in it that you're going to do machine learning on. And so if we look at this file here, uh, in fact, I guess I could just pull that into Cloud9 real quick. So if I open up another shell, I could just do AWS, or I'm sorry, AWS S3 CP, and then just do this. So copy it local. I think that will work. There you go. So that's one advantage of Cloud9. And then I could look at this file and let's see, you can just see it's basically some banking data file. So it's got, these are the columns: age, job, marital status, education. And I believe this is um, a data set that historically has who would respond to an offer for a new credit card. So if a bank wanted to offer a new credit card, hey, we have 0% API or APR for 18 months. Will you get this credit card? This will build the model about who they should send the offer to. So they're going to look at things like, the age of the person, whether they're employed, whether they're what kind of housing they have, all that kind of stuff, and how long they've been with the bank. So if we go back to this machine learning here, what we can do is start from the beginning and create a new AutoML model from scratch. So we'll say data sources and ML model. You can point it to either Redshift or S3. Now you may not have access to this if you were going to try to play around with this yourself. They, I believe, are moving it into Sagemaker Autopilot, and so this is more of like, this was like the first version of it, and I think it's now merging into SageMaker Autopilot. But the concept is the most important part. So I'm going to paste this in here, and this is the location of the data that we're going to work with, and we can just call this credit model April 11, and then I can verify it. And this is the part that I think is really cool and probably the future of what's going to be happening with machine learning. This says, does this first line contain the column names? Yes. One of the things I think that's interesting about this is that, why do we have to do all this work if there's tools that look at this? It automatically figures out which is numerical, which is categorical, does all this stuff for us, which is awesome. And now I can just say continue, and then it says, because you're going to use this wizard, tell us what you want to predict. So what I do is I toggle through the columns, and look, here's the historical data that says whether this person would accept the credit card offer or not. We're going to say yes, go to continue, and look, it's going to say you've selected a binary attribute, and this model will basically will turn it into a binary classification model. There we go. We'll just say leave all the defaults, and it will tell you essentially the setup here of how this would work. So the first part would be that this is the input. Second part is the schema, like how many numerical, how many categorical, how many binary attributes, and then we can go to continue. and then it will actually ask you a couple options. And I believe this will be the kind of things you'll see a lot with machine learning as well, is that they'll be like a recommended mode or like an advanced mode. In most cases, you probably would just leave it again the defaults, but this would be something you would do yourself with Scikit-Learn. Um, but this does it for you. So if we go here and we go review, we can go ahead and create a ML model, and it tells you exactly everything it's doing. So it takes, I think it takes like 5 or 10 minutes for it to do all of its magic. And then afterwards, you can do batch-based predictions. So this would be really similar. Like, let's say they hire you as a machine learning engineer at a company. If I wanted to impress someone really quickly, why not just set up the full system very quick? Like, sure, you can do it yourself, but if this takes you 10 minutes, why not get a complete prototype working that actually solves a problem? I probably would do that, and I can do all the coding. I think I like speed, so I may first just see, is this good enough? Because now it's an API. I can call something and I have a production API. Now, because I've already done this before, let me show you what it looks like when it's complete. Let's go to your dashboard and go to the next one. So this is one I did a while back. And once it's done, it will give you a classification report, and it'll tell you what the performance is, and it'll even tell you the ML model's quality score is considered extremely good, and it shows you your AOC, area under the curve, of 0.936, the difference, and then you can go ahead and explore the performance of it. And this is where you could change things yourself to tweak things. And so what one of the other benefits of the crisis we're in is everybody that has heard about testing with COVID-19 now knows about false negatives, false positives. And if you look at, that's one of the problems with testing currently, is that I believe that the false negative, so how many times you told someone they're negative, but we're actually positive, is actually 33%, which is really high. I mean, and that's actually very, very bad. So we actually have a machine learning model or a statistical model that people are using that is horrible. Like, it's, I mean, basically, just imagine how bad that is how catastrophic it is. Hey, yep, you're good. Go out in the world and infect people. And 1 out of 3 people, you tell them they don't have COVID-19 and they do. So you, as the author of an ML model, you can go in here and tweak this. So you could say, look, I can't afford to do that. I'm going to tweak this so that we really want to, eliminate false negatives, right? So if I wanted to do that, I could maybe tune it so that maybe it's less, maybe I'm okay with telling people that they have it, just because I want to be extra safe, but I don't want to tell them that they don't have it, right? Because the repercussions are so much higher. So I'm okay maybe with having 18% error versus because it reduces the amount of false negatives, right? You can see here's the false negative, right? So again, it's up to you as the author of a machine learning system. Is Look, in this case, you could even say, maybe that's too extreme, but like, if I want my false negative rate to be really, really low, right, I could then, I'm basically doing a trade-off, and I'm telling people that don't have COVID-19, hey, look, you probably have it, go self-quarantine. But then at least you're not, um, you telling people that do have it that they don't have it. So again, it's up to you as the machine learning author. And it seems like this is maybe where to spend more time versus writing a bunch of code that a computer can do for you automatically. So I think this is one of the future things that's going to be happening in the next few years with machine learning, is these tools. Like, why not use the tool? And then in terms of the predictions, you can also play around with this and actually just start to use it and start to prototype out predictions by using these tools. So I really like these things because they just really quickly allow you to build things and actually set up an API and use batch-based prediction. Now, the one I haven't used, so that's basically, that is AutoML. The other one that I haven't yet had a chance to use, but let me see if I can I'll try this really quick to see if I can get it to work as SageMaker AutoML. So I'm going to go to this, sure. So what I would do in the case if you want to use multiple columns is before you put it into a system like this, combine the data. So do a merge of the data. So I'll show you. I'll show you as an example. Like I have everybody's got a COVID-19 example thing. I don't think I showed you this, but this is something I'll put it into. Um, I'll put it into Slack here. But I have a project that is like a starter kit. I'm not inventing anything. I'm just it's more of like to let people play with it themselves. This is a COVID-19 thing where I grab the data from New York Times and do all the stuff with it. But basically, when we get down to here, what I do is I merge in the sugar consumption, which is a states that have high sugar consumption also have poor health because sugar is a toxin. It causes diabetes, cardiovascular disease, and the higher your sugar intake, the worse your health is typically. And then I also, so to do that, I do this, right? And so I merge in the cases, the deaths, the sugar rate, and then I also take the political data, like was the state Democratic or Republican, and then I also do that. I say merge. So you would have to pre-process it first, and then once you pre-process it, you could take something like this and then put it in, and maybe even before you put it into the machine learning system, you even could do some exploratory data analysis and do like in this case, I create a heat map that looks at the different features, and maybe you give the AutoML system the features that you think are actually important, and you use the best of both worlds. So you do part of it in Python. So we can see here, for example, that probably unintuitively people would think that Democratic states would be negatively correlated, maybe or positively correlated with deaths, but actually the Democratic states, because the typically urban and high population, high density, public transportation is typically very good in urban cities. You can see that there's actually a positive correlation with deaths by states that have voted democratically or voted Democratic. So maybe I took that. Maybe I could take this data and then I could export this and then put just the features that seem like they're correlated, right? The party affiliation, and then the state, and then I could maybe use that to create some kind of a model using AutoML. So the next thing I was going to, yeah. So the next thing I was going to show you again, this is we'll say there's a 50% chance this won't work because I haven't even tried it yet. But I'll just show you. Maybe it'll work. Is SageMaker has a beta that they gave me access to called Autopilot, and it's only available in Ohio, and you have to ask permission for it. And I finally got this set up. It's called SageMaker Studio. And what it does is it's like a fancier IDE to build, train, and debug models and monitor drifts and deploy models. So again, this is the platform idea, right? Where why would you be building all these things yourself if there's a company with thousands of employees, they're building these tools, why not use their tools? So if I click on SageMaker Studio, we can go here. Wait, let me go back here. We can go to Open Studio, and then it will open it up. Again, I've really almost not even tried this yet, so it's possible I completely fail and nothing works. But I'm gonna try. I'm gonna see if I can figure out how this would work. I believe what you do to begin with is you say create a notebook, and sure, we'll use Python 3 for data science. And then I think it says create an experiment. So I think this is where you do the AutoML. So let's try it out. We'll call this experiment name credit prediction. So if I get lucky, maybe this will work. And we know the path to the file in the bucket, right? Which was, if I go back to my, it's going to be this file. So let's go back to Sagemaker Studio. Where are you? I have too many tabs open. I have to start closing. Okay, this looks it. So I'm going to put the same file in. So if we get lucky, okay, now what's the target attribute? I believe it was, what is the target attribute? It was, let's look at one of these. Binary was Y. So the target attribute is Y. Okay. And then enter the location where you want to store the output. And we want to do binary classification. And I guess we could put the stuff inside of this bucket, maybe the demo April 10. So I'll try that. So S3 demo April 10. Make this a little bit bigger. Binary classification. Do you want to run a complete experiment? Or no, run a pilot to create a notebook with candidate definitions. That might sound easier. And then it looks like it has some advanced settings here. We'll leave them alone. So I believe, so please ensure that the bucket exists. Oh, I see. Which is fine because US, please ensure that the bucket exists in the selected region, that object. So I might need to copy I might need to copy this file to another bucket. Let's see if I can figure this out. So if I go to this file here and I download it and I go back to my bucket here and I upload it. So add files. Yeah, again, 50% chance I won't get this to work, but it would be kind of cool because this is the latest and greatest prototype for AutoML. And close this. Let's see if I go to, this would be demo April 10. Slash, does this work? Okay, no S3 file. Please ensure the bucket in the region US East under the S3. Well, I might have to wait. Error message. The bucket is in this region, US East 1. Oh, so maybe that's the issue. Is I need to go here and create a bucket, and I need to create it in US East 2, and we'll call this one autopilot. Autopilot. Because again, this is it's in beta and it only works in this US East region right now. So I think that was the issue. I think we might be able to get this figured out. So go here and I'll create this bucket. And then if I go to autopilot and I upload it, add this, here we go. Let's see if this works. It's amazing how slow that is. That seems very strange to take that long. Okay, now I go back to this and I say, again, what is it? This, grab this thing, put this at the beginning, like that. And then I can change this to, we want to just put the output here. I don't know if I need that or not, because I was going to try this one where I think it'll do AutoML and give me a notebook, but I'm just guessing here. Okay, well, that looks like it's doing something. And analyzing the data. So I'm completely blindly guessing how this thing works. I'm assuming it's very similar to Amazon machine learning, but the fact that it's built in now into SageMaker kind of tells you the direction that these companies are using, where AutoML and regular ML and AI APIs, I believe, are going to be um, are going to be really integrated, so that you just choose which one you want to use. And I guess it's a like there's so many examples of this where if your car, most cars now are coming out with some kind of self-driving mode, like every car, like you could be on the freeway and then you're in traffic and then it will ask you if it'll drive a little bit, but then you still have control over it. I think it's kind of the same thing. So here, what is this? So it says one experiment, job profile, analyzing. So it looks like it's doing a bunch of, it's giving me a bunch of components here. I actually don't know. I have no idea what it's doing right now. But it looks like you don't have any trials remaining. SageMaker is analyzing input data. Okay, did it do something? Sure. Yeah, I mean, with if you're on the free tier, and that's a good question here. If you just go AWS free tier, you're um, this actually is pretty generous in terms of you get, let's see, 5 GB of storage for free with AWS, which is pretty decent amount of storage for free, and you also get SageMaker. You could use that 250 hours. You can make 1 million requests with Lambda. So basically, yeah, just between this S3 SageMaker Lambda, you should be able, and I think Cloud9 is also included in here for free if you use the free tier as well. Yeah, you could completely do your project by using the free tier of AWS, and it should cost zero. And I think the S3 free tier um, is a great thing to use. And yeah, with don't know exactly. Maybe later I can figure out. I'm trying to go back to where I have the SageMaker thing here, but the don't know if let's see, is it giving us anything useful here? Um, I don't know what it's doing here at all, so I can't tell if it was successful. Maybe later I can look at it and if I figure out what this thing did, but hopefully that gives you a little bit of an idea of what I think the future is. The other one that I was going to show you that maybe it'll bleed into next week a little bit is that let me show you some of the stuff on GCP. So let's shift gears for a second and go into GCP. With GCP, they also have similar things. So they have an AutoML tool called AutoML Vision, and inside of Quick Labs as well, you can actually play around with these for free. And there's a couple that I would recommend that you play around with if you're interested. One of them is the Cloud AutoML Vision. I think there's two of these. One of them is called Classify Images in the Cloud with AutoML Vision. This would be a great one to play around with because it goes through and lets you use AutoML, and you kind of build it from scratch. From a high level though, let me just show you the AutoML Vision project and what it looks like. I've done there's a tutorial on training flower data, And let's see here. So I'll put this link here, AutoML, into Slack. So on GCP here, if we go to um, Vision Models, let's try that out. It's so irritating that I've been having this problem with the UI in GCP lately, where I believe that one should work, which is this is the cloud. This is the one I've been using. Let's see here. It's kind of a little bit irritating that their their UI here is not the best with projects. There's something really weird that happens where it kicks you out into this billing thing, and I'm not sure why my accounts have been having a bunch of problems with that lately. Um, yeah, so I may have an issue showing this one. I can show it next time. But here we go. It looks like this is one I can show you. The gist of it is again that you upload data to it. If we go to here and we look at the data that I uploaded, what's kind of neat about AutoML is that it will you all you need to do is point it at a bucket, and the bucket um, you'll give it a file that has all the labels and also the location in the bucket. So if you go back to this image set here and I look at it, if I say um, I think it should show me the location here. Let's see here, import. Yeah, so basically when you import data in here, you can either upload it yourself or you could select a CSV file, and the CSV file would look something like this, right? So you would say um, the location where the file lives in the Google Cloud Storage plus the label of it, and then you're later going to click on this button and then it will use that to train. So if you look at this, for example, these images here, these are all things that I would classify, and I could now toggle between them. So if you were going to train a computer vision model that looked at COVID-19 or looked at maybe there's twins, you want to have it detect different twins or something, or I've seen lots of people do different things here. Then to train it, same thing. I just go here, I go to train, and I say start training, and basically at the very end, once you train this, then you can evaluate it, and then it will be in production, and you can actually export this model to an edge-based device. So you could export it to either the Cloud Shell, I'm sorry, to what is it, like a Google Cloud Function and call it, or you could export it to an edge-based device like the Intel Movidius thing that I've shown before. So there's a lot to like about the Google AutoML solution because it's very similar to the one we did with AWS, but you just click the button and it auto trains it. The other thing to point out is that they also have tables, which is similar to the one that we looked at with AWS. And let me just find it real quick. So GCP AutoML tables, it's in beta as well. See, all these are in beta, which tells me that they're probably going to explode. Like you can see here, beta. Everybody's got one of these now. And if I go to data sets, let me just show you how you could import it. It's again very similar. We'll just call this banking like this. Create a data set, and if I click on upload a file, I could select a file from the computer, banking, and then for destination, I'll maybe make a new bucket and we'll call this banking April 11, something like that. Leave everything default and select it and then import it. And so what this would do is again the same thing that the AutoML solution would do for the AWS. What's weird about this, again, because these are both in beta, is that it takes forever to load it up, where the AWS one is super quick. I have used it to, I've actually used this in a real project before in a practicum for a data science team at UC Davis, and actually got better results for a predictive model that they were trying to use. So there's something here for sure. I think the big takeaway is that AutoML and these pre-baked APIs are very powerful. So we've basically covered um, we covered most of this before, but I'll get into some of this next week. This ML platform, but we basically covered this, and you saw that there's a lot of cool things about that. We also covered the AI API, and I think what's really left is to get into, we're like about halfway through because we've gone through some of the SageMaker stuff, and show you some of the do-it-yourself. So maybe because there's just a few minutes left here, what I could do is just show you the start of how you could think about the do-it-yourself approach, which we talk about in the final project. If I go back to this environment here, let me show you how you could start to play around with this on Cloud9 and think about a do-it-yourself model. So what we could do is go to that project, which is in GitHub, called Container Revolution. I'll throw it into Slack. So this is the sample for the final project, and a couple things to point out here. One of them is that the actual code itself is in demo here, and the components of the do-it-yourself approach here are, there's an app, and this app here really doesn't do a lot. The only things that it does that are interesting are that it scales the data. So most machine learning models require the data to be pre-processed so that they're all in the same dimension. It would be like you and a friend talking about running, and I was just talking to somebody yesterday actually that does ultra marathons, and he was like, yeah, I did. Yeah, he goes, yeah, I did a 50. And if you're talking to the wrong person, they say, oh, 50, yeah, I can run 50 meters. 50 meters and 50 miles is a big difference, right? The dimensions are very different. So that's kind of what scaling does, is it normalizes things so that you're able to um, really talk about things in the same perspective. So you do that, and then I create a route here, and this route in particular is a predict route. So this one goes through, accepts a post value, and this is what we send in. These are just variables that go into a housing prediction, and then it would return back a prediction. And what I do here is I load a serialized model off of a disk. So this in Scikit-Learn, you can say, once you train a model, you can say Scikit-Learn joblib dump, and it will just save the model to disk. So I reload it in via Scikit-Learn, and then I do a prediction. So that's basically the gist of what it would look like, and we'll go into that next Saturday. We'll start with this so we can kind of go through and you kind of go from the beginning how it works. The a couple things that you may be wondering about is, well, wait, how do you actually save that file so that I can load it in a Flask app? Well, what you can do is, in this repository here that I showed you, I have this notebooks. I should have the notebook referenced. Yeah, right here. So see this Boston housing. This is like a famous data set from Kaggle. I just took and tweaked some Kaggle data set that I saw, or project, and inside of here, there's a Jupyter notebook, and you could see exactly how I did it. So you could do something for whatever project you're working on. Something similar is, you go through here, do all the things you normally do in a machine learning project, load in data, do exploratory data analysis, do some modeling, split the data up, train it. I go through all this, fit the model, get the accuracy of the model, evaluate the model. So this would be what a data scientist would do, like something very similar to this in this notebook. And then um, what we do at the very end here, this is what I would start to do to play around with it, is I would um, create a JSON-based payload. And we've been playing with JSON with regular APIs, right? All these other APIs we're doing. And then I would make sure that that works, right? Okay, do I know how to put JSON into my model and make it work? And then what I would do is I would dump my model out. So I've got it, it's trained, it's ready to go. I'm going to save it out to disk, and then it creates this file because I say from scikit-learn.externals import joblib, and I say joblib.dump model, and the model is the thing I trained earlier. And then I would also test it out. Okay, so let's say I am going to build a Flask app, and then test it out in your notebook. So basically, if the more you test out of exactly what you would do inside a Flask, it'll be easier to debug. Then I go through and I predict it. So then basically, this is how I started to build all this. Then I took that and put it into Flask, and then loaded it into this particular Flask app and got it to run. So you could kind of use this as an example of how whatever machine learning model you're using to kind of build a workflow that allows you to both do data science and then also deploy the data science. Again, a couple of things to point out is that you don't have to necessarily do that level of complexity. There's lots that are good about it, but there's also lots that are bad about it. You also maybe you want to try this. Maybe do AutoML for a project. AI API is also an interesting one. You also could do Sagemaker. To me, these all four of these are equally good ways to think about it. There is no right answer. Um, so that would probably be a good stopping point for today. Any questions about any of the stuff that we covered today? Yeah, I could do. I could do that. That would be so the with yeah. Let's try to do that as like a as a goal to. I'll walk through the project. I'll start with that, and then the final deployment of it will let's get it running on EK. Let's see if we can get on either EKS or ECS. I think that's a good example because inside of the project here, let's see if I go back here, whatever that notebook is, um, that I do have the start of a Kubernetes application here, but it needs to be tweaked a little bit. So you could run this, for example, on your laptop, this in the state it's in now, but I would need to tweak it a little bit to run it in EKS. But yeah, I think that would probably be consume a reasonable amount of the of next Saturday, but it would be good because it would take us like from the beginning all the way to the end of maybe one of the most complex things you can do right now in machine learning engineering, which is like how do you take a notebook and every single step of the way take something and then finally deploy in a cloud environment and then manage auto scaling. So this would fit into this is the more complex. We basically got this. We've covered this in the class for the most part already. If so yeah, I think that's a good suggestion. And I'll also give you this project if you want to play with the equivalent of SageMaker. Um, you can look through here on your own, and there's some demos that you can do on GCP. The one that I did recently was this one, which is Scikit-Learn Model. So this is kind of similar. If you want to, yeah, I'll put this in there into Slack. So if you wanted to do something that's kind of similar to what we'll also do, but completely by ourselves next week, you can do this one, which it will do the exact same thing, it's going to do very similar things, but it's inside of their system. So the deploy target wouldn't be EKS; it would be something they call AI platform, which is more of can take a scikit-learn model and host it for you, and then make an API for you. So it's more like a SageMaker based platform. But yeah, I think that's a good stopping point. And then we'll probably have a little bit of time for edge-based machine learning. But this to me feels like these kind of concepts are probably the most important ones to finish off with. But even further, where we're at in class, I feel like the depth of what we covered is hopefully everyone has got like a cookbook now of all these different things that you can do with cloud computing, data, and machine learning. Any other questions? Sure. Yes, and then yeah, this GitHub project is pretty complete here, and this has from if you start with the notebook will basically bring you through exactly what a data scientist would do in a project, train a model, do exploratory data analysis, serialize it. Then the next phase you would go into this, and there's a Docker file, a Flask app, the actual ML model, um, a script that you could run. Here's another curl command that will let you do a curl to test your existing application. And then you also could hook it up into Docker, which we've done that before. And then you could also run it in Kubernetes. Sure. All right. Well, if let me know if there's any other questions. If not, we'll good suggestions for everybody. We'll start with that on next Saturday, and that'll be I think it's a pretty good wrap up, like the crescendo of what we've covered for the course. All right. Well, good luck, everybody, and stay safe, and I'll see you next week.